If your entire AI project is one prompt calling one proprietary API, you have learned how to use an API. You have not really learned how an AI system actually works. And this is exactly why I think more people should build at least one project using an open source stack. The moment you do that, all the invisible layers suddenly become visible. You have to choose the model, you have to serve it, you have to give it access to data, you have to decide what the agent remembers, which tools it can call, how you can trace it, and how to stop it from doing something stupid. So in this video, I'm going to take this Agentic AI tech stack that you see on the screen and rebuild it layer by layer using only open source tools. I will tell you what each layer actually does, which tools I would personally shortlist, and where people confuse an open source project with a hosted product. And stay till the very end because I'm going to give you 3 very specific things that you can build, plus 5 tools I would pick if I was starting this weekend. See, you don't need to learn every single logo on that map. That's actually a very terrible way to learn. You only need one working tool at each important boundary, and you need to understand how data moves between them. And if you're new to my channel, hi there, I'm Aishwarya Srinivasan. I've worked in the machine learning and AI space for over a decade, including being an AI practitioner at companies like Google and Microsoft. I was previously leading developer relations at Fireworks AI, and right now I'm building my own AI company. And I love teaching AI engineering concepts to AI builders. Now I care about this stack because understanding these layers is what helped me move from using the models to actually engineering systems around them. Now before we touch the stack, I need you to understand 3 terms. Open source software means that you can inspect the code and use it under the terms of the software license. Apache 2.0 and MIT are permission licenses. AGPL is also open source, but it comes with stronger obligations when you modify the software and provide it over the network. Now, open weights mean that you can download the model weights and run them by yourself. That does not mean the model is open source. The training data may not be public, the training code may not be public, and the model may come with a community license that restricts certain users. Now, self-hosted means the software can run on your infrastructure. It does not mean operating it is free. You may still need to pay for GPU, your storage, networking, and your own engineering time. So throughout this video, I'm going to be very precise. I will focus on open source software and openly available model weights, and I will tell you when a project also has a commercially hosted service. Please check the exact licenses before you ship anything to your customers. A GitHub repository is not a legal shortcut. I'm not going to spend too much on the infrastructure layer, so we can just skip that and move to the next layer. So let's start with the first layer as the model layer. While you can run these models directly from their model providers, the easiest place to explore this layer is using Hugging Face. Go to the models page, filter for the tasks that you care about, look at what's trending, and then open the model card before you download anything. Check the license, check the parameter count, the context length, supported languages, hardware requirements, quantized versions, and whether the model actually has tool calling support if you're going to be building an agent. I'm sure you'll see families like Qwen, DeepSeek, Mistral, Gemma, Kimi, GLM, GPT OSS, etc. I'm not going to tell you to pick one model here because the models on the leaderboard keep changing. So I would say go check out artificialanalysis.ai. It'll give you a good sense of what are the top models on the leaderboard. Or you can even pick the smallest model that can possibly do your task and build your application so that the model can be swapped without rewriting the whole system. Now that brings us to layer 2, which is a serving engine. A model file sitting on Hugging Face is not an API. You need software that loads the weight, manages the memory, tokenizes your request, generates the output, and exposes an endpoint. Now for local experimentations, I would just say start with Olama or llama.cpp. They remove a lot of the setup, support quantized models, and make it easy to get a model running on a laptop. Olama is especially convenient when your goal is to learn the rest of the stack instead of spending your entire evening configuring inference. Now when you need concurrent traffic, look at VLLM or SGLang. These are production-oriented serving engines. VLLM is a very sensible default for high throughput serving. And SGLang is worth testing when your workload has repeated prefixes, structured generations, or more complex agentic programs. So here is a mental map that you should look at. Olama helps one developer get a model running quickly. VLLM and SGLang are designed to keep expensive accelerators busy while many requests are arriving. Those are 2 different jobs. Now layer 3 is routing. Once you have more than one model or endpoint, you don't want model-specific code scattered across your application. Light LLM gives you an OpenAI compatible inference across many providers and self-hosted endpoints. It can help you with routing, retries, budgets, fallbacks, and observability hooks. The architectural idea matters more than the specific router. Your application should call a stable internal interface. Behind it, you should be able to move from one small local model to a larger self-hosted model with a configuration change. Now, the next layer is actually the knowledge and context. This is where your agent gets information that was not baked into the model weights. AKA, that's where you give it context and attach it to a knowledge base. And I want to correct a very common misconception here. A vector database is not your RAG system. It is one component inside a retrieval pipeline. Your pipeline has to ingest the source, parse it, preserve the useful structure, then split it, create embeddings, store it, retrieve the right candidates, possibly even combine semantic and keyword search, re-rank the entire result, and then place the right evidence into the model's context. If you want to go deep into RAG, I have actually recorded a very deep dive video into it, which is also on my YouTube, so definitely go check it out. Now, Llama Index is also a strong open source choice when your application is heavily centered on data ingestion, indexing, retrieval, and document agents. It gives you connectors and abstractions for building a full context pipeline. For the databases, ChromaDB is easy for local prototype. Qdrant is where I would look when I want a dedicated vector search engine that I can self-host and carry further into production. Now, if your application already lives in Postgres, pgvector may be a more practical choice because you want to avoid operating another database. Whichever one you choose, inspect your parsed data before you tune the retrieval. If a PDF table was flattened into meaningless text, the vector database cannot repair it. Now, knowledge and memory are related, but they are not the same thing. Knowledge is the external information that the agent can retrieve, such as documentation, policies, research papers, or product data. Memory is what the system decides to preserve from previous interactions or actions so it can behave differently later. MemZero is an open source tool that I would highly explore for this layer. Instead of dumping an entire conversation transcript back into every prompt, a memory layer can extract the useful facts, update them, retrieve the relevant ones, and avoid carrying all the historical text into every single turn. For example, a career assistant might remember that you are targeting a forward deployed engineering role, that you prefer Bay Area companies, and that you already applied to 3 specific teams. That is memory. A database containing job descriptions and interview guides is knowledge. Please do not save everything in memory. That creates noise, that creates privacy problems and stale facts. Decide what is worth remembering, give users a way to inspect and delete it, and test whether retrieval returns the correct memory at the correct time. Now, the next layer is the protocol layer, and this is what makes the stack modular. I'm sure you would have heard of MCP or Model Context Protocol. This standardizes how an AI application discovers and calls tools or accesses external context. I have also recorded a deep dive video on MCP, which is also something that you can find on my YouTube channel. Now, instead of writing a custom integration for every single agentic framework, you can actually expose a capability through an MCP server and connect it to any compatible client. OpenAPI still matters because a huge amount of business softwares already expose ordinary REST APIs. MCP does not really erase those APIs. In many systems, MCP server is simply the agent-facing adapter sitting in front of them. Now, OpenTelemetry matters at a different boundary. It standardizes the traces, metrics, and logs so observability does not become completely tied to one vendor. You may also see protocols such as A2A for communication between agents and AGUI for connecting an agent backend to a user-facing interface. My advice would be to learn MCP and OpenTelemetry first. Add another protocol only when your architecture has a problem that the protocol is meant to solve. Now, above the protocol, you have the tool layer. Tools are the actions that your agents is allowed to take. Firecrawl is a useful open source option for turning websites into cleaner LLM-ready content. It can scrape pages, crawl a site, map URLs, and return markdowns or structured data. The core project is self-hosted under AGPL, and there is also a hosted commercial API. Those are two different deployment choices, so do not describe a paid API call as a fully local stack. A simple research agent could use Firecrawl to collect pages, Llama Index to transform that inside them, Qdrant to retrieve the evidence, and Model to write an answer with citations. The dangerous part is that tools create side effects. Reading a public web page is different from deleting a file and is different from sending an email or running arbitrary code. I would say use least privileged credentials. Put code execution in a sandbox or in a container. Always require human approval before anything that's consequential. And always treat text collected from the internet as untrusted because prompt injection can arrive inside a retrieved content. Now the next layer is agent frameworks and the harness. Let's understand what is agent frameworks using an example of LangChain. Now, LangChain gives you reusable components and integrations for model calls, tools, retrieval, and agent constructions. LangGraph is the lower level orchestration layer I would use when the workflow has state, branching, retries, checkpoints, or human approval. The The distinction is very simple. LangChain helps you assemble components. LangGraph helps you explicitly controls what happens next. Now, if your system is primarily a document or a knowledge agent, Llama Index can also own a meaningful part of the orchestration. The point is not to force every project into one framework. Pick the framework that makes the control flow visible and testable. And please do not start with 6 agents talking to one another. Start with one agent, add 2 or 3 tools, and a clear stopping condition. Add another agent only when you can explain what separate responsibility it owns and why a deterministic function cannot handle that handoff. Above the framework is the agent harness. This is a layer people often collapse into the model, but it is also where a lot of the actual product behavior lives. The harness is what manages the system prompts, the tool definition, the context assembly, the memory, skills, permissions, retries, and the working loop, along with the environment in which the agent acts. Two products can use the same exact underlying models and feel completely different because their harnesses are different. Harnesses in simple terms are basically the plumbing or the engineering around the models. If you want to go deep into harness engineering, there's obviously another video on my YouTube channel that you can go check out. Also, if you want to study an open source harness, check out Hermes Agent from Newest Research. It is an open source agent that can run with local models or different model providers, and it includes the tools, skills, persistent memory, and mechanisms for learning from prior work. I would not begin from trying to copy every single feature. Inspect how the repository organizes the agent loops, the tools, the skills, the memory, and the permission boundaries. That will teach you far more than reading another diagram about agents. Now, this is also where you should be very careful. A harness may have access to your terminal, the files, browser, secrets, and message accounts. So always run unfamiliar agents in an isolated environment first. Read the permissions, keep the secrets out of the prompts and repositories, and put human approval in front of external writes and destructive commands. Now, the next layer, which is actually a very important layer, is for observability, evaluations, safety, and interface. Now, imagine your agent gives the wrong answer. Was the model weak? Did the retrieval return the wrong document? Did the memory layer inject a stale preference? Did Firecrawl parse the page badly? Did a tool call fail? Did the agent loop choose the wrong next action? Without traces, you're just guessing. You don't really know what's happening. That's exactly why you need observability. For open source observability, BrainTrust, LangFuse, and Arise Phoenix are strong places to start. Instrument the application with open telemetry wherever possible. You want to see the complete trace including model calls, the retrieved context, tool calls, latency, token usage, errors, and the final output. And then build evals. Ragas is useful for retrieval and RAG-focused evaluations, and PromptFoo is very practical for comparing prompts, models, and red team cases. Deep eval is another option for writing test-style assertions around LLM behavior. Now, my recommendation is going to be extremely specific. Create 30 real test cases before you even begin optimizing the system. Include normal requests, ambiguous requests, missing information cases, tool failures, prompt injection attempts, and cases where the correct behavior is to ask for an approval or refuse an action. Now, for safety, look at open projects like Nemo Guardrails, Guardrails AI, PromptFoo's red teaming workflows, and OpenGuard models where their licenses fit your use case. But do not confuse a guardrail library with a security strategy. Your real control are permission scoping, sandboxing, input validation, output validation, secret isolation, auditing your logs, and human approval. Now, the final layer of all of this is the interface. Open Web UI is a quick way to put a usable chat experience on top of a local or self-hosted models. Anything LLM is another open source option if you want a packaged interface around documents, agents, and local models. The interface is basically the top of the stack, but it should not contain the intelligence of the system. Keep your models, tools, memory, retrieval, and orchestration behind a clean interface so you can actually replace the front end later. So let me make the decision for you. Go to Hugging Face and choose one small open weight instruct model whose license and hardware requirements is something that you understand. Then pick 5 pieces from the stack. LangGraph for the workflow, QRAN for the retrieval, Mem0 for the memory, Firecrawl for web data, and BrainTrust for tracing. If your project is document heavy, add Llama Index and let it handle the ingestion and the retrieval orchestration. If you want to understand what a more complete agent harness looks like, inspect the Hermes agent. Those are the next 2 tools I would explore. Now, if you want to run some models locally, start with Ollama. Now, learning all of this on a video is fine, but you're not really learning till you actually build something. So here are 3 projects that I would highly recommend for you to build. Project 1 is a private research assistant. Choose a small model from Hugging Face or wherever you want, and you can run it through Olama on your laptop. Then use Firecrawl to collect a small set of public sources. Use Llama Index to parse and index the content in ChromaDB or Qdrant. Make the assistant answer with citation and build a 10-question eval set that checks whether every claim is supported by a retrieved evidence. This is going to teach you about the models, ingestion, retrieval, tools, and evaluation without requiring the agent to take risky actions. Now, project number 2 is memory-aware career agent. You can use LangGraph to create one agent with 3 tools. Search the saved job descriptions, compare a role with your experience, and generate a weekly preparation plan. Add MemZero so it can remember the roles that you're targeting, skills that you're working on, and companies that you've already researched and the feedback you gave it. And then add controls that let you view, edit, and delete the memories. This project will actually teach you the difference between state, knowledge, and long-term memory. It also forces you to think about privacy instead of just adding memory as a decorative feature. Now, the project number 3 is actually a production-style agent harness. As I was telling you, study Hermes agent. Then build a smaller version with a model that you found on Hugging Face. Add a LangGraph loop, have tools exposed through MCP, and build that in a sandboxed execution environment. You can even add brain trust or LangFuse traces to it. And then add one human approval checkpoint before any external write. Then run a prompt food test suite with tool failures, injection attempts, and cases where the agent should stop. If you're able to build these kind of projects, put them on GitHub and even share them on LinkedIn, this will really showcase that you have a strong engineering portfolio. Now, the useful lesson here is not that you need to become loyal to any of these tools. It is that you should understand the boundary each tool owns. If you want to go deeper and actually build these systems, do check out Gen Academy. My co-founder Arvind and I have built a 6-week Mastering Agentic AI program to teach practical AI engineering through live lectures and weekly projects. We cover all the way from generative AI building blocks to context engineering, RAG, agentic design patterns, fine-tuning, evaluations, observability, AI safety, and security. You can find that link in the description below, so definitely go check it out. And if this video was helpful, please do subscribe. I share practical AI education from the perspective of somebody who has spent more than a decade working in this field. I do read my comment section all the time, so if you have any questions or if you want me to create videos on specific topics, please do add that below. Hope that helps, and I'll see you in the next one.